Let's talk about Apollo 12, the rocky side of life. So, what about those little numbers that
Yeah,
we thought might have been for the frames of Apollo 12 for the images? You want to take
mm.
that one, Jarrah?
Yes, being the resident geologist of the group, I immediately recognized those numbers as being the identification numbers of all the different rock samples. What they would do on the Apollo missions, each rock would be identified. First two numbers would represent the mission in question, and the next three would be used for identification. So it would be like Apollo 12 sample 001, Apollo 12 sample 002, etc., etc. And so when I saw that map, I immediately recognized, ah, yeah, those are the locations of the different rock samples that they supposedly collected on Apollo 12.
Okay, well, now that we have that straightened around, how about this? I just have a question to ask. On Apollo 17, on the 50th anniversary, they're showing opening up that case that they had stored that was supposed to be vacuum sealed on the moon. But the problem I have is when I look at this case, when they open the case up, they show this bag, and all these rocks are inside of that bag that they have clearly just ripped open. Now, I don't see any numbers on those rocks, and I don't see them in separate Teflon clear bags like we do on some of the other shots. I don't see any of that. So, how could they know what numbers go where and which rock came from what crater or what area on the moon when none of them are labeled? They're just laying in a pile in there.
The rocks, they were initially numbered after the fact in the receiving lab. When they actually first opened the boxes, they take little photographs holding the little number counter thing next to them. It gives you an idea how big the rocks are. Supposedly, during the actual recovery of these samples, there were just a generalization. Okay, here we document taking this bag of rocks here, we've been taking that bag of rocks there. I remember on the documentary In the Shadow of the Moon, one of the astronauts, I forget which one, he claimed that for every rock they collected, they needed to get 4 or 5 photographs of the rock while it was in situ, so they could, use that back on the ground to say, okay, this rock is from there, this rock's from there, and that's why in some of the cases, some of the PDFs that are available on the Lunar Sample Compendium website, they have an EVA photograph of the rock laying in the ground. So it makes you wonder if they had duplicates of the rocks, fake sample prop rocks that they would put on the moon set here and there to use that for photographic purposes.
But they said that the bags were pre-labeled and that they were clear Teflon bags. Well, we found the clear Teflon bags that are sitting on the cart for Apollo 12, but you don't see them labeled. And they were saying that they were already labeled, pre-labeled, and they were just putting the samples in the bags as they were picking them up.
I put all the photographs from Apollo 12.
Yeah.
Now I'm going to just share the screen so we can all have a look at this one in particular. We have this one here. We have an idea. These are the clear plastic bags.
Yeah, I
And of
see
course,
that.
this is Apollo 12, and this one says 1364 on it. All of those are showing them as they're traveling around. This is on EVA2. There's only 2 magazines for EVA2. And that's when they walk around and get to the surveyor. So if they're using this, they don't have this cart with them. They'd have to drag this cart all the way around. It doesn't have wheels on it, so it's just kind of stationary. They did have it out a little bit on the first EVA, but the second EVA, they don't have this cart with them. There's nothing in the transcript talking about gathering or collecting rocks. They don't talk about putting them into bags. They don't talk about anything. And then here's all the photographs of them. Where are these bags? These astronauts would have to be carrying these bags with them. And you see them when they're down to the surveyor, they don't have any bags on them.
I think for the second EVA, they were just supposed to be inspecting the Surveyor spacecraft. I don't recall there being anything about collecting actual rock samples themselves.
When you see the chart where they are going around, and it
Mm.
shows where they collect all the rocks, and that's EVA2, and that's before they get to the surveyor and after they get to the surveyor. They got to be carrying these bags, and they got to have the rocks in the bags.
There was also drill samples that they supposedly collected. Maybe these samples. Let me have a look at the actual map itself, and I'll find each individual sample in the compendium.
There's the map. Now they've got these Dixie cups on this cart as well.
Okay, the first rock that's got a question mark next to it, sample 12065, is a pigeonite basalt. You can see this is where they would actually number these rock samples. They would take this little scale with the little dial on it to basically set the numbers to wherever you wanted. The first five numbers represent its identification, and the last two numbers, because you remember after they get these things back, they chop and slice and dice them up into little samples and stuff. So each little sample they would cut off, they would add an extra two numbers after that to identify which section they're talking about, which section they've cut up. Okay, so that's the first sample on the list. The next one was 62. Okay, I looked that one up. Okay, that's another basalt sample. They just have a thin section photograph of it this time. Okay, this is the Lunar Sample Compendium website where basically they keep all the paperwork concerning the rock samples. If you wanted to get a hold of an Apollo sample yourself, you'd have to basically write up a lengthy report basically explaining, okay, I want to get this sample to study it for this or for that, and could you please send me the rock sample? That's basically how you get your samples, and of course, you can actually look up any sample you want to find all the paperwork. 12065 was the first one.
The other one's 12062, which is right close to the surveyor.
Okay, but what's the point?
Well, where are the bags? You got a photographic record of them traveling around through EVA2. By the time they get to the surveyor and that, they probably got at least 20 rock samples. Where are they? Are you telling me that they unzipped their suit and tucked them inside?
I think I'm more realistic than
like, where are they? They're not in the photographs.
Well, I don't see them either.
This is one of the main problems of Apollo 12 not having any video coverage. We wouldn't be having this conversation.
They don't talk about it in the transcripts. They don't talk about collecting these rocks. If you see how many photographs they're taking and the length of time they're out there, the only thing that they'd be able to be doing would be taking pictures and gathering rock samples. I mean, it's just too much information. And they wouldn't know exactly where they were on the lunar surface where they're collecting these things.
Okay.
Somebody would have to chart that. You'd have to have a third person, like a bean counter, sitting there, with a nice clipboard and writing down exactly the location of everything on it, the photo number that is going to be attached to it, because they should have photographed the rock samples, which they didn't do. They didn't talk about them, but somehow they knew exactly where they were and what the numbers were where they gathered them. And that would have to be charted. And that would be, one of those special space pens that they'd be using.
But what about the number? You were saying that there's numbers on those bags, at least on one of those bags. I only saw the number 3 on the corner of that one bag. So where did you get those numbers from?
But this is Apollo 12. So all of the numbers, there is no 13 on it because it's Apollo 12. So every number is a 5-digit number that starts with 12.
The 5-digit numbers were added after the mission. Okay, we got these rocks in this bag. Take them out. Okay, this one's 12 so and so and so. This other one's 12 so and so and so. They just numbered them that way, you see. All they had was a documentation of which rock was from which bag, and then they numbered it after the fact. That's the way it went.
You'd need another bean counter out there charting that. Because these guys didn't have time. If they're gathering rocks and taking pictures, they didn't have time to do anything else. That number says 1364 on that bag. A 4-digit number is already on that bag.
Okay, I just found the PDFs for each of the samples on that map, which we were just talking about. Yeah, sample 65 is 2.1 kilograms. Sample 62 is only 738 grams. 32 is 1.8 kilograms. 64, 1.2 kilograms.
What's the total weight that Apollo 12 brought back?
Okay, it says the Apollo 12 returned 34 kilograms of samples, including 45 rocks, samples of soil, and several core tubes that included material from as much as 40 centimeters below the lunar surface. As for those 5 samples that are on the map, let me just add up the weight for those. You're looking at about 8.35 kilograms.
Basically, they've got 34.5 kilograms of weight on the lunar surface. That would weigh about 14 pounds is what they're carrying for rock samples.
And for this particular collection, which they collected around the actual surveyor itself, we're looking at about 8.4 kilograms.
That's about a third of their total collection. The total samples from both EVAs, when you look it up, it says it's 34.5 kilos, 75 pounds.
It says they collected 34 kilograms of rock.
But 75.5 pounds is what they collected totally. When you have that much rock and 2 guys are walking around with these bags, whether it's a clear collection bag or it's a what they show as almost a canvas bag, a white bag for collection bags. Where are they in the photographs? They're 6 hours or 6.5 hours on their thing around to the surveyor and not have these bags with you.
I remember
Okay.
when I did my geology excursions, my various geology excursions, I was always the kind of the bag guy. I would carry samples and samples in my backpack, and I remember how heavy it would get after a while.
Yeah, well, they already have a backpack on and it's already full of equipment. So they can't
Mm.
put bags in there. Like I said, they could unzip their suit and tuck them in an inside pocket, but that's a little difficult in a vacuum. They have pockets down on their legs, but you can't have that much volume to put in those things because they already have tools in there, right? They carry their
It's actually
hammer in that lower leg pouch and stuff like that, and then their sunglass pockets up here, so they can't put rocks in there. And then on the other shoulder, they have their space pen, their Fisher space pen goes in that pocket over there. I mean, if you realize that they were faking it at Flagstaff and they went out and they practiced and they came back and they practiced and they came back with these rock samples, that's how the cue cards were created. And they were done months ahead of time to be on their wrist. This map of where they were picking them up could have been done months ahead of the impossible flight, which becomes even more impossible in today's age when they can't even get the SLS off the ground.
I just did the calculations. Those 8.4 kilograms of rock amount to about 25% of the total collection from Apollo 12. I just did the math on my phone here,
Yeah,
so yeah.
yeah.
Well, now, speaking of the SLS, why don't we just have Jarrah explain that one? Because that is quite interesting how Artemis 3 has now been scrubbed for basically what's going to turn into an Apollo 9 mission to test the equipment around the Earth. Well, we supposedly they did this in Apollo 9, and that was what, 56, 7 years ago, when they should have had this all worked out. Now, Artemis 2 is being delayed even further. Jared, you would like to explain that to us, please?
Yes, now, so obviously they've been having a whole bunch of problems with the Starship, which they're intending to use as the lander. As we've seen from the previous tests, the damn thing can't even reach orbital velocity despite the tanks being run dry of fuel. They just burn it to depletion and it still can't reach orbital velocity. And so obviously you need to get into orbit before you start refueling this thing. And then, of course, there's a bit of a back and forth with SpaceX and Blue Origin. They're both competing for the lunar lander contract. They call it the Human Landing System. They have their Blue Moon lander, and there's a potential Artemis 3 now might fly with either Starship or it might fly with the Blue Origin Blue Moon lander. But either way, that's now going to be essentially a modern day repeat of the Apollo 9 mission, which was a test of the mothership and the lander in Earth orbit. Okay, and so now essentially that's what Artemis 3 was supposed to be, the first human landing in the Artemis program. Now it's become a modern day equivalent of Apollo 9. And of course, Artemis 2 mission has been postponed now to at least April because even though they completed the wet dress rehearsal, they've had problems with the helium tank. The helium tank is, of course, supposed to pump the helium into the propellant tank so it can push the propellants into the combustion chamber. And now there's leaking, and so that's going to be another whole kettle of fish that they've got to try to fix up. They've taken the SLS, back to the vehicle assembly building, and they're going to have to start taking things apart to try to find where the leak's coming from, try to weld it up. And of course, the O-rings of the solid rockets, because the
Ah.
SLS is essentially built from space shuttle hardware by design. It inherits many of the flaws and shortcomings. They can't launch the SLS at a temperature below 53 degrees Fahrenheit, or they risk a catastrophic O-ring failure like you had on Challenger. And likewise, they also can't test the wet dress rehearsal. I do need to be clarifying here, the wet dress rehearsal is just a test of the liquid rockets. Basically, you could simulate a full countdown up until the last minute, or the last few seconds rather, and then do an abort. Then you have to basically vent out the hydrogen and oxygen tanks essentially. You see, they can't do that in the cold because remember, the liquid oxygen, liquid hydrogen, they're using cryonics, they're using cryogenic storage tanks. And so if it's too cold on the inside, too cold on the outside, that actually puts a great stress on the tank and risks its structural integrity, risks a tank rupture.
So then why did they get rid of the helium tank in the LEM for Apollo 15 then, if they needed it? Because this is supposed to be pushing out the fuel. So now are they going to say, well, let's just open the solenoid up and The vacuum of space just pulls the fuel out of there. Why didn't they need that back then, and yet they need it now?
Your guess is as good as mine. One key difference, of course, I've noticed with the LEM and, of course, with the SLS, of course, is that the LEM uses hypergolics, and so it doesn't really need an ignition source, anything like that. You just put the propellants together and they ignite spontaneously together.
But when you look at the diagrams that they have online, you always see that the helium tank is only used to push the fuel out for the retro systems. You don't see that on any other system in there when you look at the piping. Of course, I don't know because many times we find this to be wrong. So your guess is as good as mine. But the point is that they still got rid of that helium tank on Apollo 15 so they could strap that rover to it. They need
Yeah,
the
the first
helium.
three had a helium tank to push the fuel out, and the last three didn't because they needed to have a spot for the rover. I was not aware that these systems on the SLS still had a bladder design. The helium's pushing it against a bladder.
The LS is, for all intents and purposes, essentially a Frankenstein creation of the space shuttle technology. It's actually something interesting. I was actually looking at this book a while ago. Right, I purchased this back in 2009. I went to United States to attend Ralph Renee's funeral, or more accurately, the scattering of Ralph Renee's ashes in New Jersey. During my time there, I had visited other places. I had visited the Goddard Space Flight Center. I visited the Air and Space Museum at the Smithsonian, where they have the Apollo lunar module. They have the CSM from Apollo 11 on display and a few other spacecrafts on display. And at the gift shop there, I picked up this book here called Project Constellation, Moon, Mars, and Beyond. It's basically a little pocket guide touting basically what they were proposing back during Bush's time, back when it was called the Constellation Program. On page 16 here, they've actually got a timeline of events. Now, on page 16, they actually have a table of events. This is what they actually were proposing for the Constellation Program. And they use their acronyms here as well. Let me just get their page for the acronyms open as well here. Okay, here we go. Now, in 2008, they say RLEEP1, which is the description is LRO and LCROSS. RLEP1 is, of course, the Robotic Lunar Exploration Program. So these are like robotic precursor missions. In 2009, they've got Ares 1-1, first stage Ares 1 test launch. That ultimately flew as Ares 1X, which, of course, was the first and last flight of the Ares rocket. And in 2012, they've got a second Ares 1 launch test. Then in 2013, they list Orion 3, which they describe as being the first flight. I assume it's an unmanned flight because there's no crew listed here. Then in 2014, they're expecting 3 flights of the Orion. They're expecting the first 2 missions to the ISS. The first one is uncrewed. The second one is crewed. Then there's a cargo mission. Then in 2015, they're expecting a whopping 5 flights of the Orion in 2015. Operational ISS mission and cargo to the ISS. So yeah, they're expecting at least 2 crewed missions to the ISS with Orion and 3 cargo missions. Then in 2018, they get into the Ares 5 rocket, which is a test flight. Then in 2019, they list LSAM. LSAM was what they called the Lunar Surface Access Module, which was basically their equivalent of the Apollo Lunar Module. It's listed as LSAM-2, so I assume there was going to be a lunar lander test on the first Ares 5 launch, but it's not listed here. Also in 2019, they're expecting the first lunar orbit mission of Orion. That would be Orion 12. Then Orion 13 is supposed to be another lunar mission. And Orion 14 in 2020 is supposed to be another lunar mission. Now, later in the same book, they've got another table here where they go into more detail about those flights. Let me find it. Here it is. On page 35, they say that lunar landing with Orion 13 and LSAM-3, 2020. Lunar landing with Orion 14 and LSAM-4. The Constellation project was something of a bastard child of Earth Orbit Rendezvous and Lunar Orbit Rendezvous, in which they would use separate rockets, 2 rockets. They would use an Ares 1 and an Ares 5, launch the lander and the mothership, the Orion capsule, into Earth orbit. They would dock in Earth orbit, fire the Earth departure stage, and head off to the moon. Now, interestingly, the big departure from Apollo is that the Lunar Surface Access Module was what was supposed to do the lunar orbit insertion burn, because it was much, much larger than the Apollo lunar module. So it does the burn to enter lunar orbit, while the Orion capsule does the burn to get out of lunar orbit. Even though they dock in Earth orbit, they have a rendezvous in lunar orbit as well. But ultimately, all we ever saw of the Constellation program was LRO, LCROSS, and the first Ares rocket. It was cancelled under Obama. Obama, he says, oh, we can't afford to waste the taxpayers' dollars as if it's monopoly money. That was his exact statement. Obviously, he came under fire for that, and then there was a change of plans to make it an asteroid mission.
But you were saying this Artemis II now. When is it scheduled to launch again?
It's supposed to be launching in April at the earliest, but now there's talk about how they might have to postpone it until the end of 2026 because they're experiencing quite a lot of high solar activity right now, and they reckon.
Oh, really?
They've been listening to us.
Not the action.
They're taking it back to the building and pulling it apart to redo the seals as well, right?
Yeah, exactly.
Because it sat out there from December into freezing weather.
They said it sat out there for 1 month and 2 days.
Space.com. Artemis II moon mission shouldn't launch until 2026. New analysis of solar superflares suggest. There's a quote in there by Vasco Herrera. I'm probably butchering that pronunciation of the name, but that person represents the National Autonomous University of Mexico. And they reckon that the mission should be delayed even longer than until April. They say, given how active our sun is right now, our forecast suggests that delaying the launch until the end of 2026 may be a much safer decision.
Well, that's what Stefan Burns has been saying all along, and that's what we watch. We watch him, especially Scott. Scott follows Stefan Burns, and he's been saying this for some time.
When he's up to date, the solar events that are happening and the type of impact that they're having, and he explains the fact that even though it's an intense flare, we may not hit it directly. It could be an intense flare, and just because the way we're orbiting, that we're going to go through it as well. Yeah, every time I just want to sit there and say, well, if it's got that much radiation hitting, we're protected, but the moon isn't, then how come these rocks don't have a radioactive signature? They've got to have.
Well, the radiation that you get from the sun is technically the protons, the electrons, and some heavier particles. What happens is they often say that the moon is, quote, radioactive. It's a bit of a loose use of the term. Radioactive refers to unstable isotopes that want to break down to become stable isotopes by basically losing parts of their subatomic structure. But in the case of the moon, what actually happens is when the particles impact the lunar surface, it actually sends secondary radiation up from the ground. So you're getting secondary neutrons from cosmic rays and from solar flares. Okay, and so that only happens while the rocks are actually being pelted by this solar radiation. You take it away from there, all you're really looking at now is just the radiation that's embedded in the rock.
The absorbed radiation. It's got to build up over time, and it has to be more than what we have on Earth. But any documentation I've seen from NASA says, well, it has the same radioactive signature as rocks on Earth.
But the Earth has the Van Allen belts to protect the rocks and us and every life form on this planet. You don't have that on the moon, my friends.
Sorry, if I may just say, I would like to discuss the radiation signatures of the Apollo samples. I believe I discussed this on our last live show. I believe Charlie Duke actually brought this up during his debate with Bart Sibrel. He kept arguing, what about the radiation signatures in the rocks? By this, he would be referring to the presence of various radiation-induced isotopes that are in the rocks. Helium-3, neon. So basically, all these different isotopes that would have been embedded in the rock sample. Well, there's two ways you can get that. First of all, if they were using meteorite samples, then those signatures would already be there anyways, because obviously the meteorites, while they're floating in space or whatever, they'd be, constantly pelted by all the same radiation as well, so it would be there to begin with. If we were using Earth rocks, such as the case of the sample that was proven to have come from Earth, Apollo 14 sample 14321, Big Bertha, which the Earth meteorite, if you were using Earth rocks to try to pass off as moon rocks, what you would want to do is you would want to put that into a particle accelerator and basically fire large fluxes of protons and heavy nuclei at this rock sample to create the signature. 26 years ago, there were experiments at the Saturn Particle Accelerator, this large synchrotron. They would put rock samples and metal samples, basically simulating stony and metallic meteorites, put those in the path of this high-flux proton beam. They were able to simulate cosmic ray exposure rate in the order of like 3 million years over a few days because of the high flux. Of course, in space, you'd have to look in square meters to start finding at least one of the high-energy cosmic rays. This thing, they basically got a larger flux of these things so they could do it much faster, get a similar age to what they would supposedly be experienced on the moon from these samples.
we need to discuss in this is the loss of custody of the rocks themselves when they were stolen. That has to go in when we're talking about moon rocks as well, right?
But then again, now that brings us back to Bart, because when Bart was on Danny Jones talking to Charlie Duke, he brought that up about how you could age these Earth rocks very easily to make them look like they're millions of years old.
Yeah, that's just to be clear, that's referring to the age. There's a cosmic ray exposure age, and then there's the actual age of the rocks. Those are two different things. But yes, that you would use the synchrotron to simulate the cosmic ray exposure ages, which basically tells you how long the sample has been exposed to this kind of radiation. If you know, okay, we're getting this much radiation over this much time, the rock has that many radiation impacts in there, we know, okay, it's been in space for that many years. That's what we use to determine how long a meteorite or whatever has been floating around in space for.
So then how long would you have to leave an Earth rock in a synchrotron in order to make it appear that it's 3 million years old?
Well, to simulate the 3 million years, using the fluxes that were specified in that report, it was something like 6 to 12 days to simulate a 3 million years exposure.
Wow. So basically, it's not difficult to do then.
Not difficult at all. You know, you have to put the sample in the particle accelerator, you just accelerate the protons or heavier nuclei at it, and you'll get the same effect. Same effect as you get in the vacuum of space with all this radiation hitting the rock samples.
Then that brings us to another area about Professor Dave, because Professor Dave was going off on the age of these rocks and how Bart was wrong and how he's a fake and all these other things that he was saying. And I remember you sent me a little list that you had placed in his comment section. I don't know if he ever got back to you or not, but Dave was quite wrong on a lot of little points that he was making.
Start by saying is that I actually earned my degrees in astrophysics and geology, watching his videos. He would put out little educational tutorial videos, basically to try to intended for college students. So I actually watched a lot of his videos, earning my degrees. I watched them in preparation for exams or during assignments or this or that. The things he was saying about radiation and the rocks was just mind-boggling because I would have expected better from him. Well, I left a comment specifically about the radiation on his video. He never got back to me, but let me just get the comment up. I got a screenshot of it here. As somebody who earned his B.Sc in astronomy and astrophysics, watching your online tutorials, your segments on radiation profoundly disappoint me. Firstly, at 24 minutes and 34 seconds, you say that protons take the form of alpha particles. This is wrong. A proton is a hydrogen nucleus stripped of its electron. By definition, an alpha particle is a helium nucleus stripped of its electrons, and consists of 2 protons and 2 neutrons, bunched together. It even says so in your graph, which might I add is a gross oversimplification. While it is true that paper stops alpha particles, it is fallacious to assume that aluminium will do a much better job at stopping them. As I learned in my first year physics lab practical, replacing the paper shield with the aluminium shield produces an even higher radiation count than our unshielded control count. This is because the alpha particle undergoes fragmentation, with the alpha particle stripping into its individual subatomic particles that are then detected as secondary radiation. Any proton with enough energy will penetrate a given amount of metal just as well as X-rays or gamma rays. NOAA published some estimates for proton doses that an Apollo crew would have received inside the CM, LM, and spacesuit, respectively, had they been exposed to the August 1972 solar flares, and such calculations consider protons between 10 MeV and 70 MeV. Secondly, the math you show at 1631 is fundamentally incorrect. A particle flux is given by the number of particles per square centimeter per second, not the number of particles per cubic meter per second. I assume you made a typing error or something somewhere. Even so, when I did the math, I got a very different result. Not sure where you got your formula from, but here's my calculations using the formula that I was taught to use. Assuming a flux of 10 to the 5 protons per square centimeter per second, E equals 100 MeV, and a body mass of 72.5 kilogram, parentheses, an average of the lower and higher ends of the mass range that NASA accepts for astronaut selection, close parentheses, I got, and I did the calculation, and I found the dose would have been approximately 1.589 gray per hour. And to convert that to rads, you simply multiply by 100, and I got 158.9 rad. I say changing it to 10 to the 4 protons per square centimeter per second reduces it to approximately 15.89 rad. An average of these two is about 87 rad. Even if we take the lower end of this range, because protons have a radiation weight factor of 5, the resulting equivalent dose would be approximately 80 rem. this is hardly a safe dose. Care to reevaluate your data? He never responded to that.
Let's just take a look at it this way. What would it take, or how many rads would it take to make a human being sick?
Well, it would depend on the type of radiation that's affecting you, because as I said in the thing, the protons, they have a radiation weight factor. All particles, all electromagnetic waves, all types of radiation have their own unique radiation weight factor, which you've got to multiply the absorbed dose by to calculate. So for electrons and X-rays and gamma rays, the radiation weight factor is 1, right? So whereas with protons, the radiation weight factor is 5. Okay, so 500 gram is generally said to be a lethal dose to humans. And so if the radiation is gamma rays or X-rays, then you would need about 500 rads to kill a person. If it's protons, you would only need about 100 rads to kill a person because, 100 times 5 is 500.
Well, there you have it.
There was several other things that he said, specifically just about the Apollo samples. Professor Dave, he claimed, and I quote, "The lunar samples contain no hydrated minerals, unique oxygen isotopes nowhere present on the Earth, meteoritic glass formed in a vacuum of space, solar wind implanted noble gas compounds." Well, there's several things wrong with this statement here. First of all, the rocks do contain hydrated minerals. They contain hematite, which is a form of ferric iron oxide, which is associated with the water contents. The glass crystals, they contain up to 1,500 parts per million of water. The rocks themselves contain up to 6,000 parts per million of water. This is well within the range for the water in Earth rocks. Okay, He claimed that the oxygen isotopes were different from the Earth. That is just wrong. The oxygen isotope signatures of the Apollo rocks are identical to that of the Earth rocks, which ultimately led William Hartmann to conclude his giant impact origin theory of the Earth. The idea was that the Earth was struck by this Mars-sized planet, which kicked up all this dust and debris, all this molten rock up into space, which later clumped together to form the moon. In addition to the isotope signatures, they also have similar chemistry and mineralogy to that of the Earth. So the theory was that if the Earth formed from this collision, obviously the moon would contain the same stuff as the Earth, contain the same materials, right? But any water would have been vaporized in the explosion. The very foundation of this giant impact theory hinges on there being no water in the rocks. And so, when they first got the rocks back, they noticed, okay, there is indeed water in these things, but they think, oh no, it's just contamination. But now they start to find, okay, maybe it's not contamination. And now there's geologists all around the world desperately trying to make the theory fit, whereas others are starting to see the light and at very least are rejecting the giant impact theory. Okay, and so, it's progress, I guess. The meteorites on Earth also contain meteoritic glass, and so would rocks purposefully shot at by micrometeoroid samples using light gas guns. I assume when he's talking about the meteoritic glass, he's talking about all the little meteorites that would have been hitting the rock samples. There'd be glass samples in there. And of course, there was also the matter of meteoritic glass in the Apollo samples. Well, meteorites collected on Earth also contain meteoritic glass. I assume he's talking about, any glass that would have been produced, or deposited there by, meteorites colliding into the samples, micrometeoroids or whatever. And so, as I said, there's also that stuff in meteorites collected here on the Earth. And if they're using Earth rocks, you could get that same effect by purposefully shooting micrometeoroid samples with light gas guns. There were actually experiments back in the 1960s to retrieve such micrometeorites from the edge of space. They would send up, high-altitude balloons or sounding rockets that would literally open up. I think it was called the Venus flytrap. They literally would open up, the nose cone would open up and expose itself to all these micrometeoroids that are falling from the sky and basically, be collected in there as samples.
This is interesting because I remember a couple of videos ago, Simon Dan was actually saying that Wernher von Braun had never gone to Antarctica and there's no images of him ever shown. Well, I'm sorry, Dan, but we do have pictures of Wernher von Braun in Antarctica with his team. So I don't know where you're getting this information from. I mean, perhaps it's along the same line as Dave when he started attacking Bart on the show. And I'd like to just go over something that Bart had to say in his defense, which I agree with. Firstly, if they really went to the moon in 1969 on the very first attempt ahead of schedule, with 1 million the computing power of a cell phone, which they cannot even orbit the moon 57 years later with, then why would he spend so much time and effort refuting idiots? Because that's what Dave said. Professor Dave said that moon landing deniers are idiots. And then lastly, if they really went to the moon in 1969 on the very first attempt ahead of schedule, with 1 millionth the computing power of a cell phone when it cannot even orbit the moon 57 years later, then the amount of evidence that I have to the contrary is zero. Thusly, any debunking video should be 0 minutes and 0 seconds long. The fact that it takes 3 exhausting hours of painstaking effort to debunk an argument from a supposed idiot is proof itself that the argument of the moon landing fraud is quite strong indeed. But don't take my word for it. Let's listen to what Bart has to say himself.
This is Bart Sibrel of Sibrel.com. Ever since I was interviewed by Joe Rogan about the moon landing fraud, 100 or more debunking videos were produced and uploaded to YouTube to reassure the now doubting public of the claimed authenticity of the supposed obvious, yet still 57 years later unrepeatable, 1969 moon landing. Firstly, if the alleged moon landings are so obviously real, then why do they need the support of 100 recently and urgently produced videos unless the original claim is actually made of straw? This in and of itself proves me right, as there would be no videos debunking me if I said Mickey Mouse was the first president instead of George Washington. Secondly, if NASA really walked on the moon in 1969 on the very first attempt within an 8-year goal to do so, ahead of schedule after only putting one person in space for 15 minutes and with 1 millionth the computing power of a cell phone, even though NASA can only orbit the moon with dummies 53 years later, despite having nearly 6 decades of better technology and being 8 years behind schedule just to loop around the moon one time with people 57 years later, if Honorable President Nixon's 1969 moon landing claim is so obviously true, then why would anyone spend so much time, effort, and money refuting a bunch of supposed fools who believe that the government is corrupt enough to lie to that degree? This is proof itself that debunkers have made a god out of the supposed moon landings, whose God I have offended, their fuming anger from which clouds their perception of reality, believing against logic that greater technology can exist in 1969 than today, which again proves me right. Thirdly, if the foundation of a debunker's argument is moon deniers are idiots, then what they are really saying is that anyone who thinks differently than they do is an idiot. It seems to me that only an idiot would say such a thing, proving that their arrogance has blinded them from being able to perceive the truth, which proves me right yet again. Fourthly, if the truth were on a debunker's side, then they would not have to resort to attacking the messenger with repeated name-calling insults like a juvenile on the schoolyard. The fact that they do so as their manner of argumentation proves their lack of maturity, and thusly great gullibility, to think that they so confidently know what did or did not happen on the faraway moon before they were even born, as attested to by a corrupt government that has been caught numerous times murdering their own people. The immaturity of these juvenile name-calling insults as part of an intelligent discourse about CIA deception proves me right once again. Lastly, if NASA really walked on the moon in 1969 on the very first attempt with an 8-year goal to do so, ahead of schedule after only putting one person in space for 15 minutes and with 1 millionth the computing power of a cell phone, even though NASA can only orbit the moon with dummies 53 years later, despite having nearly 6 decades of better technology and being 8 years behind schedule just to loop around the moon one time with people 57 years later, then the amount of evidence that I have to the contrary is zero. Thusly, any debunking video should be 0 minutes and 0 seconds long. The fact that it takes 100 or more videos, just one of which needs 3 exhaustive hours of painstaking effort to debunk an argument from a supposed idiot, is proof itself that the argument of the moon landing fraud is quite strong indeed. Proving me right yet again.
And I agree with him on that, because you just don't go and start throwing attacks at people, calling them idiots, imbeciles, moon landing deniers, or idiots. I don't care even if it's the flat earth. You don't say that in a public setting like that, not on Danny Jones or any of these podcasters. It's just rude. You don't do those kind of things. And then Dave sat there with such a smug, arrogant look on his face. I don't understand where this man is coming from. He's supposed to be a professional scientist. You don't do those kind of things. I'm sorry. And if you throw out attacks like that, calling people frauds and idiots, well, that's an ad hominem attack, and you're attacking the person and not what he's representing. And that's wrong, because anyone who starts throwing insults has already lost the argument. That's just the way it is.
I'd have to say, there's one thing that he actually said, Professor Dave, what he said in his video. Bart had made a comment of, if somebody claimed that Mickey Mouse was the first US president, there would be no need to make rebuttals to that. And Professor Dave says in response, people make a content debunking dumb shit you say because you're successful in brainwashing a lot of people. There are other things that people fall for, which is just as stupid as Mickey Mouse being president. That's worth debunking too. Anything that lots of people fall for should be debunked. Here's my response to that, okay? A true event does not need to be defended with lies and character assassination, and yet going through each one of these, quote, debunk websites, that is 90% of what I find. There's nothing but character assassination and outright false claims. In fact, David himself made many of these in the video, like his claim that Bill Casing didn't work as an engineer at Rocketdyne, despite his employment records clearly saying that he was a service engineer. Or his false claim that the Apollo flags only waved when they're being touched by the astronaut. We have video of David Scott running past the Apollo 15 flag, and it's waving on its own accord. The Apollo Lunar Surface Journal went through 6 or 7 different excuses to try to justify this movement. Each one was rejected for one reason after another. Okay, in the end, they settled on, oh, it must have waved because he brushed it with his pliss or his elbow or something. No. And yet, if you look at frame-by-frame analysis of that thing, you can see the initial movement of the flag is just before he runs towards it. Yep. It's like he pushed some air into the flag as he's running towards it. So we know that it can't be physical contact that moved the flag. People often say that Casing didn't work as an engineer. We had got records of him working as a service engineer. When that's pointed out, they tried to undermine it. Back in 2009, we contacted Rocketdyne, right, asking them what would this job as service engineer entail. Okay, now at the time of the contact, the Rocketdyne, they were owned by Pratt & Whitney. This is the response that was received from Brian Kidder, who was the Rocketdyne's communications director. He says, "Thank you for your interest in Pratt & Whitney Rocketdyne. In answer to your question, I can only offer a generic answer as to how a service engineer was defined during the time period in question. A service engineer would have provided technical support for actions like equipment processing, transportation, installation, checkout, and for the launch itself. This would have been either when the product was in the field, ready for use, or during analysis prior to delivery to the customer." That's what Brian Kidder, the communications director, told us. Okay, so clearly this is hardly an unscientific job.
But then again, every time you look at these guys like Professor Dave or Dave McKeegan or Simon Dan or Creaky Blinder, it's always debunk, debunk, and more debunk. So I think that they either don't understand what that word means or it's misused and abused, because it's all those guys do. Well, this has been debunked thoroughly and that's been debunked thoroughly. Well, this time we're going to debunk you.
I would like to get back to what he was saying about the rocks and stuff like that, regarding the meteorite glasses that are in there and stuff. This, of course, leads us to the massive back and forth between the scientific community about the composition of the glass there. There was arguments that the glass was very similar in composition to tektites. You know, some geologists were arguing as a result of that tektites came from the moon. Others were arguing, no, tektites, they were formed on the Earth from meteorite impacts. A tektite is basically glass. When a meteorite crashes into the Earth, it sends up all this molten rock and glass up into space, which then collapses and falls back down to the Earth. We find these little glassy fragments, which are tektites. There was reports that tektite glass was found in the Apollo samples, which of course led to various back and forth between the scientific community as to whether or not tektites formed from the moon. And of course, what he was saying about solar wind impacted noble glass compounds. Of course, as I said, we have the particle accelerators, which were used to simulate cosmic ray exposure ranges in as little as 3 days or 6 days.
So on Luna 24 then, did they find any of these glass fragments in that soil when the Russians examined it?
I believe there were glass fragments found amongst the soil that they collected, but most interestingly enough is that none of the Soviet samples were reported to be rusted or anything like that. No oxidation or anything of the sort. The Luna 16 and 20 samples were reported to be bone dry, and only the Luna 24 sample was reported to contain water, up to about 1,000 parts per million of water, and that was only found by drilling deep under the soil. It was collected from a depth of, I think it was 1.5 meters under the soil. Okay, and only it contained up to 1,000 parts per million of water. Remember, the Apollo samples supposedly had up to 6,000 parts per million of water in the surface materials, and the only place where comparable amounts of water have been detected remotely is, of course, in the polar region. That's, of course, is because in the poles you can get permanently shadowed craters and much cooler sunlit areas, which is why you can happily get comet water accumulating there. And that's also the only place where they've been able to remotely detect signs of rust. And of course, the Chinese samples, they've reported to look vastly different chemical-wise from the Apollo samples. There was an article published by the Chinese where they said, this is a direct quote, "The first results from the Chang'e 5 lunar soil research have been released. They are very different from samples donated by Apollo in the United States." They say, in addition, the original plan for the Chang'e 5 lunar sampling was to take 2 kilograms of soil, but the fact that only 1,731 grams were taken, the reason may be that the density of the lunar soil was wrongly calculated. The basis for our calculation was the density of the lunar soil is the 1 gram of lunar soil donated by the United States. The United States may have concealed key data. Therefore, and this is the kicker, although we do not doubt the authenticity of the US moon landing, it is more and more doubtful whether the lunar samples it sent as gifts, especially the 1 gram of lunar soil it sent to China, really came from the moon. So it's interesting that Chinese would actually publish this article saying, well, we don't doubt the missions to the moon, but we do doubt the rocks they gave us.
Well, that reminds me of Chandrayaan 2. When you take a look at those images of Apollo 11 and 12, and you compare those to the LRO, we have to ask, where are the tracks? You don't see boot prints. That's what I mean by tracks, the boot prints, the drag lines from the boot prints. And yet you can see the landing pads clearly on each of those images. So if you can see the landing pads, then you're going to clearly see the tracks. But you don't. And that's the same thing you're saying. As soon as another country goes and sends something to the lunar surface, supposedly, then guess what? It's different from what we're shown in Apollo. To me, that makes no sense. That just shows you something's not right with any of it.
There were many other things Professor Dave was claiming in his video regarding radiation that I feel are worth addressing. I've got it right here and stuff like that. Now, there was one section in Bart's interview on Joe Rogan's show when he said that after the first Orion test flight, which I believe was in 2014, he had contacted them, requesting an interview with Scott Kelly. When it was declined, he asked for the data they were measuring on the Orion project. Now, just for some context here, the Orion test mission, it carried 2 battery-operated independent radiation detectors. They call them BIRDs. That's what the acronym stands for. They had 2 of these radiation detectors aboard the Orion spacecraft, and Sibrel was saying that when he asked for the data from those detectors, he was told that it was classified. Professor Dave responds with a complete straw man of what Bart was saying. He says,
"Nope, no such data is classified. The radiation data have always been public. The radiation dose encountered by the astronauts is documented and public on the NASA website. Van Allen probes recorded huge amounts of raw radiation data, and other countries also have their own individual radiation readings, all converging to the same range. He is pulling it out of his ass that anyone would say that any of this is classified. It isn't. Lying liar McLiarton supreme."
So that's not what Bart was talking about. He was specifically talking about Orion. Then he goes on to talk about the Van Allen probes, which were two missions that encircled in and out of the belts for several years. They're no longer in operate now. But he seems to think that Sibrel is talking about the Van Allen probes, and he goes on to make a straw man out of that, saying that that data has never been classified. Well, Bart wasn't talking about the Van Allen probes. He's specifically talking about Orion. Now, I spoke to Bart about this. I asked him, when did you request this data from NASA? He told me he requested it about 30 days after the mission, okay, which would put that in early January of 2015. The Orion flight was December 2014. Bart tells me he contacted them about 30 days after splashdown to request the data, okay, which would put that in about January 4th, 2015. Well, since then, the Orion data had been released. It was published by NASA on June 1st, 2015. If they were released in June 2015, it was not available to the public, and by definition, it would have been classified. So that makes Bart's statement correct. By the time he contacted them, NASA was withholding this data, okay, and they hadn't been released yet. Now, I've got the actual readouts from the thing. I actually looked at their report. First of all, right, it's important to note that the Orion spacecraft has about 20 grams per square centimeter of shielding. They actually have a graph which they compare what they were predicting using the AP9 data. Okay, they called it the AX9 because, like, AX9 refers to the proton and the electron data. They're comparing it to they were expecting, right, from both particles. Now, if you look at the actual document that they published, you see that the predictions for the radiation under a shield of 20 grams per square centimeter is actually less than what was measured. The actual recordings from Orion are more consistent with what they were predicting under a shield of 10 grams per square centimeter, which demonstrates that they were picking up much more radiation than they were anticipating. The actual data from these birds, they recorded 1.57 rad and 1.79 rad respectively. After converting this to the equivalent dose, since they're only in the inner belt, we can assume that it was protons. You multiply that by 5, you're looking at 7.85 rem and 8.95 rem respectively, or a total of 16.8 rem. Again, this is close enough to what Van Allen was freering and fretting over in his reports that Bart constantly referred to Van Allen's Scientific American article from 1959, where he said that a human being exposed for 2 days to even 10 roentgens would have given only an even chance of survival. So this obviously presents an obstacle to spaceflight. That's what Van Allen was writing in his report. Much more recently, we have data from Artemis I. Unlike the Orion EFT-1 brute check, as Dave put it, the Artemis I flew a more direct translunar injection along a similar inclination to that of Apollo. As we've seen in their report that was released, rather than look at the radiation as a whole, they only wanted to focus on one effective dose. You see, you've got the absorbed dose, which is the amount of radiation deposited in a body of mass. You've got the equivalent dose, which is where you've taken the absorbed dose and you've multiplied it by the appropriate radiation weight factor to determine, okay, what kind of ill effects you'll have on there. That's the equivalent dose. And now an effective dose is the equivalent dose multiplied by a tissue weighting factor. Each part of the body has its own tissue weighting factor, which basically is a fraction of 1. Okay, say only my lungs have been affected by the radiation. Okay, I'll multiply the total body dose by the tissue weighting factor of the lungs, and it'll give me the partial body dose for the lungs. Okay, and so you look at the table from their report, you see there's only a selection of organs listed. You've got Helga's lungs, her skin, her stomach, her uterus, and her spine listed. Okay, now you can look for the lungs and the stomach. The tissue weighting factor is 12. That represents 12% of the overall dose. The skin, interestingly, represents 1% of the overall dose, and so when you recalculate for the full body dose, obviously the rest of the organs aren't listed, but you can do some back-of-the-envelope calculations to determine the full body dose, okay, based on the tissue weighting factors. Doing the calculations, we're looking at somewhere between 9 to 12 rem based on the lungs or the stomach doses. Scarily, the skin dose would imply a full body dose of 130 rem. That's all discussed in my latest OLIS article, and of course I discussed that in my video about the Artemis II mission, because the Artemis II isn't expected to have a direct flight through the belts, as was the case on Artemis I. It's going to do an incremental thing where they have two highly elliptical orbits. One will put them in the heart of the inner Van Allen belt. The other one is essentially a Molniya orbit, which by design, Molniya orbits are not recommended for manned flights because they make multiple trips through the belts. They're a very lengthy, highly elliptical orbit. But of course, a Molniya flight has this stupid high inclination. Artemis II is supposed to be much more inclined closer to the equator. It's going to be in much more intense regions of radiation.
Yes, but when you look at this part, this is what I like about this math, because you're saying doing the proper math, I've got a very different result. And then you're going through the protons per centimeter, I believe, squared, and then, 3,600 per hour. And anyway, you're breaking it all down. Then when you do the recalculation for only 10 to the fourth protons per centimeter, I believe it's the way you have it all worked out, it works out to 15.889 rads per hour. And then when that's taken along with the radiation weight factor for the proton, which is 5, so yes, that's a lethal dose. And yet Dave says it's not.
This just completely boggles the mind. First, he provides one formula for the thing, which basically involved multiplying the flux by the amount of time by, quote, the shielding factor. Where did this shielding factor come into the thing? If you know a proton at a given amount of energy will be stopped in the shielding, you just simply exclude it from the calculations, or you only calculate the secondary radiation that would have been delivered in the form of gamma rays or X-rays. Okay, if you know something is going to be stopped in the shield, you simply exclude it. I mean, when I was doing my calculations using the AP8, the AP8 is the industry standard model for the proton belt, okay, right? When I was doing the calculations, the report by J.W. Keller et al. Suggested that any protons up to 8 megaelectron volts will be stopped in the shielding. Okay, so I excluded everything below 8 megaelectron volts in my calculations and only focused on everything above that. Dave provides this one thing, and then he does something completely different, and neither of them are correct. As I said, it's fundamentally incorrect. You see, as I said again, an absorbed dose is simply the energy divided by the mass. And of course, to calculate the energy, you first convert from protons per square centimeter per second into protons per square meter per hour, and that's how I calculated the hourly dose. It's all explained in my math here. Okay, we've got the flux, which is given in particles per square centimeter per second. Okay, to convert this into square meter per hour, right, we take 100 square centimeters and multiply that by 3,600 seconds, because that's how many seconds there are in an hour. Okay, we've got that. Now we've converted it from protons per square centimeter per second to protons per square meter per hour. Now, the surface area of a human is 2 square meters. Okay, that's why I've multiplied it by 2 square meters. Each particle has 100 megaelectron volts. Okay, so I multiply it by that. And now I want to convert it to joules. 1 megaelectron volt is equal to 1.6 by 10 to the minus 13 joules. Okay, so now we've got our energy. We simply divide that by the mass of the astronaut, and it gives us our 1.6 gray per hour. Okay, so when you want to convert that to rads, that ends up being about 158.9 rad. Okay, and as I said, I did the same calculations again for the lower end of the flux that he specified, and I get 15.89 rad. And again, an average of those two is 87 rad, and so this is hardly cause for celebration. The numbers that he specified seem to support the opposite of what he's concluding.
I remember we were talking, and you were saying something about Dave Farina losing his credibility and citing this demonstration that Dodd was proven a sycophant for Elon Musk.
Yeah, there's one section where he was citing experiments that Tim Dodd had made. Tim Dodd, of course, being the everyday astronaut, as he called himself. Right. First of all, right, he was citing the experiment as proof that shadows should not go at 90 degrees. Well, first of all, it's not going to go 90 degrees due to perspective alone unless you're using something like a fisheye lens. That was even shown in Tim Dodd's experiment.
There is one thing that I would like to say about that experiment. Tim Dodd really, how can we say it, screwed the pooch on that one. I have another fella here who is actually a lighting engineer, and he did some calculations and he ran an experiment, but he showed it with his CAD software that using one single light source, you can actually have those converge the way that it was in the Apollo images. So we would have to actually do a proper experiment with the camera at chest height to reproduce that, and the sun angle would have to be the same.
Yeah, well, getting back to what I said about this thing about thinking of that is, I feel that Dave Farina has basically damaged his credibility by trying to cite stuff from Tim Dodd, because Tim Dodd, in fact, Thunderfoot actually has grilled him a few times on this. Tim Dodd has demonstrated himself to be a complete Elon Musk sycophant. He's constantly hyping the Starship thing even long after it's been proven to be vaporware, and even after he himself got screwed by the whole Dear Moon scam. He was supposed to be flying around the moon aboard the Starship with that Japanese guy and several other people, right? And what happens? Oh, they cancel the thing, right? That's after it was demonstrated that the ship can't even reach orbital velocity. Does he call him out on this stuff? No, he continues to side with Elon Musk even long after he's demonstrated to be, spout what he promised with Falcon 20 and what was ultimately delivered with the Starship were drastically different. And Tim Dodd is still spoofing this guy, basically still touting this guy as if it's going to be their savior to get to the moon and Mars. I've seen Professor Dave, grill actual charlatans, like there's that one anti-vaxxer who was spruiking this miracle drug as opposed to vaccines, and he actually lost sight in one of his eyes, right? Oh, does he criticize the drug he spruiks? No, he still criticizes the vaccines. Well, why aren't you criticizing Tim Dodd? For the same reasons, it's literally the exact same logic.
Problem is, Jarrah, when you have a channel that has that many subscribers and you have NASA backing you with the funding that they have, you're not going to be able to win. You're going to have to show some pretty hard evidence because people are going to believe these guys. And I mean, look at Phil Mason. How many times have YouTube gone after his channel? How many times have Google tried to take him out? It got to a point where you couldn't even find Phil Mason Thunderfoot in any search on Google. They literally removed his name from the entire system. And that's what happens when you call these people out. They don't like it. And it's the same with Apollo. Why can't these people understand that, look, Artemis is going nowhere? It's been grounded. It keeps failing. It's amazing how they can get dummies there all the way around to the moon and back. But as soon as you add the humans into the equation, it's canceled repeatedly. And it's the same thing with this Todd fella. Canceled, right? Because it's too dangerous. And even Elon Musk says that it's more difficult to get into low Earth orbit and stay in low Earth orbit. That's the difficult part. We were going to also discuss the Starliner. Look at that disaster. That almost killed 2 astronauts. And Boeing was the ones who built the Saturn V rocket. So tell me, how come they can't make the technology today that they did supposedly back in 69 to 72, and they actually claim to have landed humans on the lunar surface and bounce around and do all these foolish tricks and jumping and falling, and you think that you would tear your suit open the first fall anyway, but that's beside the point. The point is that Artemis can't get there. Musk's rockets keep exploding. So people are do well to start asking questions.
It's a huge stark contrast between then and now. It's like they've lost their ability to produce anything that works. Yeah. It's astonishing. And Dave actually, in his video, he kept hyping about, oh, well, it's very expensive to send humans to the moon. Well, here's my counter to that. The total cost of the space shuttle, the International Space Station, all these things that they've spent sending astronauts to low Earth orbit alone, it greatly outweighs what was spent on the Apollo program. And there's been all these proposals, throughout the years to try to get back to the moon for cheap. There was proposals back in the 1990s to use the shuttle. They wouldn't be sending the shuttle to the moon itself, but they would basically have a lunar lander in the shuttle cargo bay, right, which would have been derived from the Apollo technology. It would be like a command capsule with landing legs attached. Okay, they would deploy that by the shuttle, and Orion 5 or a Titan rocket would launch a Centaur upper stage the lander would dock with, and they would send that to the moon. Okay, it would land on the moon and make the return to the Earth. That was called Early Lunar Access. That was an actual proposal back in the 90s, okay, to get to the moon for cheap. They didn't do it. Then they had the Zonda program that was launched using a Proton rocket, which is still in service today. And of course, the Zonda itself was a stripped down Soyuz capsule. Essentially, it was a Soyuz capsule without the orbital module. It was just the re-entry module and the service module, right? The Soyuz is still in service today. Obviously, you would need to thicken the heat shield somewhat, to get up to speed with what they had back then. But, it's still existing technology. They could easily loop a cosmonaut around the moon right now, but they haven't done that.
Remember the Russians, they said that they would send a cosmonaut to the moon when they deemed it safe. And obviously they hadn't deemed it safe because they haven't done it to this day.
I mentioned this in my notes. In fact, Rene was the one, he dug this information up as well, is that in 1963, Sir Bernard Lovell, the English astronomer, He actually visited the Soviet Union, and President of the Soviet Academy of Sciences, I believe his name was Keldysh, he told Bernard Lavelle that they were postponing the manned missions to the moon indefinitely because they could see no way of shielding the astronauts from space radiation. And it's important to note that from the beginning, the Soviet spacecraft, they were flying with sea level cabin pressure atmospheres, okay, which by design means you need much thicker walls than what they were using on the Apollo capsule, because the Apollo and the Gemini and the Mercury capsules, they all used a low pressure pure oxygen atmosphere, like 3 to 5 psi of pure oxygen. If you were to try to fly with a sea level pressure atmosphere, the capsule would have ruptured in space. Okay, so they had to use a low pressure atmosphere on Apollo and Mercury and Gemini. The Russians, they had the luxury of flying with a sea level pressure atmosphere, so already they've got much thicker walls than they do on Apollo. Right, and they can see no way of protecting their guys from the radiation that's out there. So the Russians, they could see no way of shielding their cosmonauts, rather, from the space radiation, despite having vastly superior shielding on their capsules, as evidenced by the fact that they were flying with a sea-level pressure atmosphere. The Americans had to wait until the shuttle for that luxury. Now, there's one thing that Professor Dave was talking about, the Orion capsule. He was arguing that Mike Kelly's comments about trying to solve the issues refer only to the electronics that are aboard the space capsule. First of all, the Orion spacecraft has about thrice as much shielding as Apollo. As I said, the Orion capsule was 20 grams per square centimeter, whereas the Apollo capsule was 7 to 8 grams per square centimeter. So all the electronics that are inside the Orion capsule are sheltered by a superior shield. Okay, claiming that we need to solve the radiation hazard before sending humans there makes no sense in the context of flying the electronics in a previously less shielded capsule through these belts like 9 times, or actually 18 times if you count the return trip. It doesn't make any sense. And now, there's another thing that he said in there. He says, modern electronics are more susceptible to electromagnetic disturbances than the analog equipment used in Apollo. But Bart can't have his viewers understanding all that now, can he? Well, actually, the opposite seems to be true right here, because the analog technology was also quite robust against radiation. I need to specify, first of all, is that modern electronics that the Orion capsule would have been using would have been silicon-based electronics, microchips and that sort of thing. I've got a passage from the book Prospects for Interstellar Travel by John Malden, and this came out in 1992. He writes, present space missions use ordinary silicon electronics, somewhat radiation-hardened and resistant to mild radiation. So right now they're using modern technology which is somewhat resistant against radiation. Now Van Allen, writing in 1961 about the electronics that they would have carried into space, this is from his December 1961 Space World article. Van Allen says, the radiation tolerance of electronic and other physical equipment is generally vastly greater to that of animals. Typically, cumulative doses in the order of millions of Roentgens are required to produce important effects, though characteristics of semiconductors in critical circuits may be appreciably affected by smaller doses. He goes on to say that the electronics aboard the Vanguard 1 and the Sputnik 3 survived 2 years in the radiation belts. So contrary to what he said about the electronics being weaker than what we have in the modern stuff, is the exact opposite seems to be true. Both the electronics in the 1960s and the electronics that they had in the Orion capsule are vastly more resistant to the radiation than humans. And again, the Orion spacecraft has the thicker shield, has a thicker radiation shield. So claiming that they need to solve the radiation problems to see if the electronics work doesn't make any sense in the context of the electronics are flown in a much weaker shield, and yet it survived no problem whatsoever. And again, the Orion spacecraft has the thicker shield, has a thicker radiation shield. So claiming that they need to solve the radiation problems to see if the electronics work doesn't make any sense in the context of the electronics are flown in a much weaker shield, and yet it survived no problem, so it seems.
This is the problem that I have. I will go and I will look around and I will say, I want to ask AI a couple of things, a couple of questions when it comes to this astrorad shielding. Actually, it was Google's AI that said that they're going to be placing some of this astrorad shielding in selected panels. Now, I don't really know what selected panels means, but in my opinion, if they're going to come back alive with human cargo, I don't care if they're just going around to the moon or they're going down to the moon. They're going to have better shielding than just an aluminium hull. Because, like you said, I don't know how many times we've shown that video of that fellow holding a piece of aluminium in front of that radioactive substance. And it scatters all over the room and the readings go sky high. It just scatters everywhere. Now, cosmic radiation, okay, well, it's not going to be, concentrated like it is what this fellow's doing. But like you were saying in class, it still scatters. It scatters, which means it's going to be going through you. It's going to bounce off the walls, go through you, bounce off the walls, come back, go through you again. And it's going to just keep doing this. And eventually, it's going to make you very sick. Now, I don't understand why they cannot understand that concept when we're actually showing it in a video of this happening live. And yet, why isn't this happening with these missions that they're sending?
I was completely shocked by what he was claiming about the alpha particles when he was claiming that protons are alpha particles. Keep in mind, I actually graduated watching this guy's videos, his lectures about space and about this and that, earned my degree in astrophysics from that. I was absolutely astonished that he was claiming that protons are alpha particles. No, a proton is two protons, two neutrons joined together, and he was constantly citing that oversimplified diagram of alpha particles being stopped in paper, claiming that if the paper will stop the alpha particles, or protons as he calls them, won't go through the metal. That's just wrong. As I found in my class, when we replace the paper with the aluminium, the alpha particle undergoes fragmentation, and it's registered as a secondary dose, which is much higher than what we counted for no shielding.
But the funny thing is no matter how many times I show that video, these guys still don't get it. Like, for example, you take Dave McKeegan or Simon Dan. I mean, they're avid followers of Professor Dave and vice versa. So they're all in it together, and yet they can't see this. It's staring them right in the face. The experiment is being conducted right there, and you can see the readings on the radiation counter.
They can do it themselves.
Just like we did the film. We had university tested, in fact. It's not only fogged, but the hues have gone wild. And yet they won't do the experiments themselves. That's what gets me.
I would love to see the look on Dave Ferner's face if he was to do the same experiment that I did in my class. Take the little radioactive source of the alpha particles, put that in front of your Geiger counter. Here's your unshielded control count, something like 2,000 counts per second. Okay, put your paper piece in there, about 2 or 3 counts per second, that's expected. He expects that if we put the aluminium in its place, it'll be even lower count, or even better count. If he was to actually do that, it would be much higher than what he got for the control count without the shielding. And that's because the particle is being fragmented, and of course this applies to any heavy particles that would have been encountered in solar flares or the belts or wherever else. Any heavy particle that encounters this aluminium is going to get fragmented, and I found in my test that to stop the secondary radiation, I needed to put a layer of lead underneath the aluminium to absorb these fragments. Here's a guy who claims to have been a high school teacher and a university professor. Okay, how could he possibly make that mistake by claiming that alpha particles are protons? I can't believe I'm making this comparison. I tell you, it literally gave me flashbacks to that flat earther I debated on Fight the Flat Earth's channel. It was claiming that pressure is mass.
K0 is not a mass, it is a pressure. Mass is not pressure.
Pressure is a mass on a surface. You don't know.
It's not the same physics. As mass on its own.
You don't know physics. You don't.
What did he just say?
You do not understand how to rearrange an equation. Seriously.
You don't know physics, man.
That hurt.
In air is working because we have the outside pressure. PO is the pressure outside. And I'll tell you one more thing. Pressure is a mass.
No, pressure is a function of force, and of course force is a function of mass. Being a function of mass does not make the function itself a mass. That's what I was saying, and so it's just boggles my mind. How could anyone claim, his claims to have taught university students, how can anyone claim that protons are alpha particles? Alpha particles are literally helium nuclei. It's 2 protons, 2 neutrons bunched together. A proton is literally just a proton. It's a hydrogen nucleus.
Well, now we know where Simon, Dan, and Dave and the rest of them get this mix-up from. I don't know what else to say.
I meant what I said with all sincerity. I was absolutely astonished that he, of all people, would make this ridiculous claim that protons are alpha particles and do this completely botched math for the Van Allen belts. Unlike the actual charlatans and idiots he debunks, I actually graduated watching his videos. I'm equal authority to be talking about the stuff that he's putting out there and stuff. I am equally matched in wits and stuff. When there's an actual crack in his armor, I can actually see it, and I know how to exploit it. Unlike the charlatans, the actual charlatans he responds to, who just want to see holes where there are no holes. I see an actual hole, and how could he have missed that hole? Okay, and so I don't know whether to call it a betrayal or a punch in the gut, because that's just, I'm just disappointed is the only word I can really describe, because I earned my degree watching this guy's videos, and he drops this turd on us. Drops this turd claiming that protons are alpha particles and does this completely botched calculation which makes no sense whatsoever. And his own numbers seem to support the exact opposite of these conclusions. Beggars believe how he could have missed that.
Yeah, I like Professor Dave. Out of all the things that he says, I mean, the guy has a lot of good points. He makes a lot of good videos. But this time, yeah, he dropped the ball on this one. Yeah.
He didn't just drop the ball, he missed the whole match. He tripped at the goalpost, tripped at first base. Hey everybody, it's Jarrah here. I'm talking to you from post-production. Looking back at this three-part series as a whole, we covered mostly the demonstrably false statements that Professor David said about radiation and the Apollo rock samples. But there were also some pieces of low-hanging fruit that he pushed as so-called gotchas that he claims definitively proves Apollo was real. For the sake of thoroughness, and to avoid making another video about them, I'm going to address them now. Let's start with the obvious ones. Firstly, on the topic of lunar laser retroreflectors, Bart Sibrel cited the fact that the Soviet Union also claimed to have put retroreflectors on the moon.
In 1958, according to Scientific American magazine, they were bouncing lasers off the moon without any man-made reflectors thereon. So all they had to do was choose a landing site that had reflective surfaces. Additionally, Russia put an unmanned probe on the moon with laser reflectors.
Yes.
So that doesn't prove anything.
To which Professor Dave responded,
Yeah, of course light bounces off the moon. That's how we can see the moon, genius. But that's scattering. You only get back a tiny percentage of whatever you bounce off the moon. These are retroreflectors, not mirrors. You can't bounce a laser off the lunar surface with the precision that you can off of a retroreflector. And the Russian ones have different coordinates and reflectivity. It's easy to distinguish between the two.
"This is a straw man. Bart is not claiming that the Americans are passing the Soviet retroreflectors off as their own. He's arguing that if the Soviets could do it with unmanned missions, so too could the Americans. And in fact, NASA's retroreflectors were originally intended for the unmanned surveyor missions. Secondly, Dave frequently brings up the topics of the Russians tracking the Apollo missions, all the way to the moon.
At the time of descent, the Soviets even radio tracked the entire path of the lunar module, and that's been public information since the 60s. And again, the Soviets were tracking the spacecraft throughout the trajectory. They would know if they were in LEO pretending to be farther. Flying around in LEO requires speeds of Mach 25. They would be going 17,000 miles an hour. That would result in a Doppler shift that is measurable. None of this works.
This is false for multiple reasons. Firstly, at the time of Apollo 11's descent, the Soviet Union was on the far side of the Earth, the side facing away from the moon. Secondly, translation of this Russian article states that the only dish the Soviets had tracking the Apollo missions was their TNA-400 facility. Originally, it wasn't built to receive frequencies used by Apollo, and the upgrades to do so were only completed by November 1968, just before Apollo 8. Even then, the Soviets were limited to only listening in during the time Apollo was said to be in lunar orbit or otherwise near the moon, because NASA had not supplied them with the ballistics data. Thirdly, even had the Soviets tracked the Apollo craft all the way to the moon during the descent, they of all people had already demonstrated with their Zond 5 mission how to fake a manned mission to the moon such that radio operators would be fooled. As Pavel Popovich once recalled, "When we realized we would never make it to the moon, we decided to engage in a little bit of hooliganism. We asked our engineers to link the on-the-probe receiver to the transmitter with a jumper wire. Moonflight missions were then controlled from our command center in Yevpatoria in the Crimea. When the probe was on its path around the moon, I was at the center, so I took the mic and said, 'The flight is proceeding according to normal. We're approaching the surface.' Seconds later, my report, as if from outer space, was received on Earth, including by the Americans. The US Space Advisor Frank Borman got a phone call from President Nixon, or should I say LBJ, as Popovich's memory seems to be in error, who asked, 'Why is Popovich reporting from the moon?' My joke caused real turmoil. In about a month's time, Frank came to the USSR, and I was instructed to meet him at the airport. Hardly had he walked out of his plane when he shook his fist at me and said, 'Hey, you space hooligan.' You can't make this stuff up.
No.
Clearly, to fake the Apollo mission such that radio operators would be fooled, all that would be needed is an American repeat of the Zonda 5 hoax. Send unmanned probes to the moon as repeaters to relay Apollo telecommunications from Earth orbit and to make them appear to have originated from that far away in space.
Oh, and Dave, before you further embarrass yourself by citing the Zon 5's biological payload, the turtles, the insects, the bacteria, spiderwort plants, and so forth, before you cite those as so-called proof that humans can survive the journey, friendly reminder, all of those life forms are extraordinarily radio-resistant, meaning they can harmlessly absorb huge amounts of radiation. Turtles alone require tens of thousands of Roentgens to die, far in excess of the lethal dose to humans. Professor Dave, trying to get as much mileage as he can out of the dubious Everyday Astronauts video, also made a fuss over the lighting, claiming that it cannot be done on the Earth.
And their argument is it would actually be more difficult to fake the moon landing than it would be to actually go.
Well, that's not true. Was the film The Martian shot on location in Mars?
Was The Martian shot on Mars? That's a feature film for entertainment purposes, you nitwit. Yes, it would be harder to fake the moon landing than to do it. We just demonstrated that it would be physically impossible to fake those images on the lunar surface. You can't illuminate everything as we see in those images any other way than by sunlight. So if it's impossible to fake, that means it's easier to go.
Notwithstanding Apollo photos that have uneven spreading of light across terrain, and shadows diverging, as Dave noted would be expected from a nearby light source, HBO demonstrated how to evenly light up a fake moon set, complete with parallel shadows. The moon scenes were shot in a 298 square foot blimp hangar, and the set was evenly lit up simply by shining an array of xenon spotlights into a large convex mirror, which in turn illuminated the moon set evenly. Again, complete with parallel shadows. So this gotcha is moot.
Well, when I first saw the moonscape, I guess my reaction was, this should work.
Our director of photography, Gail Tattersall, has created an amazing sun effect, which is really what sells this as being real.
The solution turned out to be using a convex mirror about 6 feet in diameter, and then projecting into it the most powerful spotlights that are available in the film business today, which are 10K xenons. There were only 15, I believe, in the United States, and we had to have 5 made extra just to be able to get our brightness level up to being able to record on film.
I would say the light that we have created to simulate the sun on the moon is probably one of the single brightest light sources ever created for anything.
We figured out it was going to be very hot because when we were doing tests for this, my best boy was lining up xenons with welder's glasses on, and his hair almost caught on fire.
And finally, another one bites the dust.
Faking such footage is essentially impossible, especially on the lunar surface. Looking at the trajectories of dust particles, no turbulence due to zero atmosphere, every speck following a parabolic path indicating a vacuum, these are the minutiae that jerks like Bart are completely incapable of addressing.
And yet I addressed it way back in 2008, nearly 20 years ago. The dust, when kicked up by the astronauts, or shot up by the wheels of the rover, behaves very similar to how dry sand would be kicked up on a beach. It arcs and comes back down again without forming clouds. Thus, to fake the dust trajectories seen in the Apollo footage, I proposed carpeting the fake lunar surface with dry sand topped over a layer of wet sand, which will allow for the so-called dust to be kicked up in a parabolic arc while still allowing for the formation of boot prints and tire tracks. Again, I addressed this way back in 2008. Nice to know how up-to-date you are, Professor. Well, over to you, old me. I remember when I did my astrophysics course, before I could even sit certain physics courses, I needed to sit 4 math courses, 3 in the first year and 1 in the second year. It was brutal, but I learned through blood, sweat and tears and through the help of a great teacher. When my final math lecture was over, I kid you not, I stood up on my seat and I said, "Oh, Captain, my Captain." Now, imagine if some stage after that, my math lecturer turned around and said, 1 + 1 = 3. Well, that's exactly what we had with Professor Dave. His errors on radiation completely defy comprehension, such that I'm completely astounded.
I still can't believe how he screwed up on that particle business.
This is one of the most basic things that they teach us, and like any proton with enough energy is going to penetrate metals just as well as X-rays will do.
Yeah, he dropped the ball on this one. Yeah.